Well, hi everyone. Thanks for being at this session. It's always great to see so many people interested in unit testing and testing in general. My goal today is for you to start, well, those of you who want to. I'm not going to force anyone, but those of you who want to actually start unit testing some code today. It can be a very simple unit test, but I want you to, if you want to start doing it today, I want you to be in a position where you can do that. And to that end, the session will be a very practical. There's going to be very concrete examples, and I will stick around the room for as long as necessary in case some of you have some technical questions or want to show me your code or want to actually get to a point where you're running unit tests on your computer today. My name is Albert. I've been working especially with testing of all sorts for about 10 years. So unit testing, functional testing, end-to-end testing, accessibility testing, code quality testing, copy-paste detection, linting, all kinds of things that have to do with automating, just making better code. And it is my opinion that any code which is not tested or any functionality which you present to a client which is accepted and which makes its way into production without associated tests is actually legacy code from the moment it gets put into production. And someone at some point is going to have to deal with that legacy code, so you're incurring technical debt, and that person is probably going to be you. So D-Cycle, which is my shop I work at, is basically doing almost exclusively testing, consulting to clients or teams who are at that point where they need to start doing some automation around testing. The presentation is you can have the presentation on GitHub, and I would also invite you to look at the on the website of the Drupal camp. In the description, there's a link at the very bottom, which basically to a blog post which goes over all of what we're going to take a look at today, with links to code, links to the presentation, and so on. So if you want to get some more information or you don't have to take notes, everything is in here. Perfect. So let's look at some non-testable or non-tested code, let's say. And to make this kind of realistic, I decided to go and take a look at some code that's actually being used, a Drupal module that's being relatively widely used, that has 0 tests. So let's take a look at that now. I chose a module which is called Automatic Entity Label. I don't actually use this module myself, so I don't know exactly what it does. Here is basically, there's some quite good usage, 34,000 sites using it, there's a Drupal 8 release, and there's no testing here. So what I did is I took this code, and your code probably looks somewhat like this right now. So you have code that's being used, works, relatively well structured probably, but there's no testing. I took this exact code and I put it on a GitHub, here it is, on a GitHub project called Unit Test Tutorial. All right? And so this is the exact code that we're going to take a look at today. We're going to make this code, we're going to add unit tests to this code. So I found that instead of taking some kind of like ideal code or some example code, I took some real world code so we can have access to real world problems that crop up. Now, if you follow along with the tutorial on the blog post, you'll notice that I added tags as we go along, as we add new concepts, or as we look at new concepts, they're corresponding to different tags on the GitHub repo. So tag 1, if I check out tag 1, is basically my initial commit here, which is the untested code. We'll take a look at that now. There it is, unit test tutorial. So as you can see here, There's nothing that resembles any tests, but it is organized in such a way as you maybe are used to with the classes. You have some procedural code here as well. This is basically the type of code you're probably dealing with, whether you have custom code or contributed or are managing contributed modules which are untested. Okay, so that's the untested code which corresponds to what you have now, and we're going to move forward to this exact same code but with unit tests later on. So step number 2, and these steps are actually correspond to the tags as I mentioned. So I found that very often when you look at tutorials online about adding unit tests, they showed you how to add unit tests to code, but those unit tests don't provide any value because it's basically, it doesn't make any sense for me anyway to add unit tests or any kind of test to code if you don't have a continuous integration system to back that up and to test those on every commit. So just adding unit tests, it's fun from a technical standpoint, but it doesn't really add any value to your organization. It doesn't have any return on investment. So for me, it's useless, like from a business perspective. And doing continuous integration without some sort of DevOps behind that, where you can reproduce the exact same results on your local computer very easily and on a continuous integration environment. So again, it's very, very hard, and it's hard to maintain, and people tend to not do it. So we need, in my opinion, the first steps is to have some sort of continuous integration set up, some sort of DevOps type system where I will use Docker in this example. And by the way, the Drupal testing environment, or the TestSpot, does not use Docker. You have to kind of set it up, which is a bit of a pain. So I'll use Docker myself and something called CircleCI to run my automated tests, and it's pretty easy. I'll show you how. And later on in the talk, we'll take a look at how to use a Drupal testing infrastructure in case you have, like, you're submitting core patches or contrib module patches or managing a contrib module. But if you have custom code for a client, I would go the route of using something like CircleCI. So that's tag number 2. Let's check it out. And I'm going to take a look at the diff here between tag 1 and tag 2. And this is basically how I added unit tests to, continuous integration and Docker to my code. So the first thing, have any of you don't use Docker on a regular basis or not exactly sure what it is? So you all use Docker except you. You. Don't be shy. It's okay. We all went through that. So I'll just quickly take a look at what basically installing Docker is just doing a web search for Docker desktop, installing it, running it, and it's going to show you this little, if you use a Mac, it's going to show you this little icon at the top here, and you just turn that on, and that's all there is to it. And at this point, what you run locally through Docker is going to give you the exact same results almost always as what you run on a continuous integration server which uses Docker, which makes things super easy without having to install and configure any software on your local computer. So I did install Docker, and I'm going to see if I can. So basically here, if I want to run, let's say, PHPUnit on my local computer, it doesn't work for some reason. It's not the right version. I get this fatal error, the configuration's not right. So I don't use PHPUnit. This is probably something I installed ages ago. However, if you go in and run PHPUnit through Docker, wait a minute here. Okay, well, it's an internet issue, basically. Sorry about that. Well, if you run that through Docker, you're going to be, and I'll show you the results on the CI environment. So right here, I'm having, let's see here. Yeah, it's basically an internet firewall thing. But normally, if you're on a regular network, you'll be able to run the exact same thing locally and on your CI environment. So I'll show you the results from the CI environment. Sorry about that. We'll look at the CI environment. Now, first of all, just see how to set this up in the code. Now, my kind of approach to using these CI systems like CircleCI is to avoid vendor lock-in. So a lot of these systems have you write like super long YAML files that are very specific to one CI environment that tries to install things, specific version. You have to keep track of that. So instead of doing that, I just installed Docker on the CI environment. And here is basically what the config file looks like. You're going to be able to have access to that directly. You just run that. There's nothing else to do. You put that into your code into a file called .circleci/config. And basically, you can add like a little nice badge here that shows you if the code is passing or not. And here the test states that it's going to run ci.sh, which is a shell script, which basically runs exactly. Oh, I think I made a mistake in my example earlier. Yeah, I think it's PHPUnit. That should work. There it is. So running. So yeah, I was wondering why that was happening. Okay, so if you run PHPUnit through Docker, it kind of just works if you don't make a typo like I did. So this is like the first thing I would encourage you guys to do, to actually add this exact code to your code base. Then log on to CircleCI, or if you want to use some other service, probably works well as well. Here's CircleCI, unit test tutorial. You just kind of add the project, basically. Here, unit test tutorial. I just added, set up project, and it just kind of works, right? It takes a few minutes. And here is what my initial test looks like. If I look at my first test results on my CircleCI system, well, unable to find image, it fetches the image because it didn't find it, and then it says, yeah, CircleCI is running. That's my first test. I now have Docker installed, I have CI installed. So whatever I do on my code base starting now is always going to be automatically run on my CI environment every single time. So moving on. Unit tests don't have access to a full environment. Let's add our first test here and check out tag number 3. So basically what I'm doing is, I'll actually show it to you, because there's a few things that CircleCI PHPUnit needs. So this is my changes between tag number 2, in which I added CircleCI, and tag number 3, where I actually have a test. So I added an autoloader, which basically states that where to find my files. So in this case, for example, my namespacing system, Drupal /auto entity load label, you probably have some sort of namespace system as well, is unknown to PHPUnit. PHPUnit doesn't know what Drupal is. Okay, so you have to kind of tell it that, okay, when you're looking for the namespace Drupal / in this case auto entity label, you actually need to load that file somewhere. So in this specific case, I added an autoloader. You can just copy paste this and change it with your own code. But basically, I'm saying if I have something that starts with Drupal auto entity label, I just replace that Drupal auto entity label with src, and I get that class name and add PHP to the end. I load that, and that's all there is to it. That's basically a standard autoloader. There are some standards here which you can use when you do it through Composer, but this is I like to do it like this so I have an understanding of what's going on. The PHPUnit XML file is pretty straightforward as well. It just basically says, load my autoloader before anything else, and here are my tests in the tests folder. So here it is, the tests folder. I added one test here. And I also changed my Docker run command to add -v, which basically takes my local code base, my present working directory, and shares that with the /app code directory on the PHPUnit Docker container. So again, you just copy paste that and it should just work. And here's my test. Let's take a look at that test. And this is a pretty kind of, let's say, the simplest possible test I could possibly run. So in my test, I'm using Drupal auto entity label manager, which is this thing here. And due to the autoloader, here is the actual class. And due to the autoloader I just used, my PHPUnit knows to get that by loading a certain file. And I'm asserting that calling this auto entity label visible static method, if I go back here, where was it? Here it is. Where is that? Auto entity, here it is. Auto entity label manager. There it is. Okay. If I call this function with something other than profile 2, I should get false. And if I call it with profile 2, I should get true. I don't really care how this works. This is not my code. This is just code I took from a random module on Drupal.org. But I know that that seems to be what it's supposed to be doing. So that's what I'm going to test for. Going back to my test, here's my test. I'm just asserting that when I call this with whatever, okay, it's not profile 2, it's just whatever. It should return, in this case, I said false, but it should return true, okay? And that's what my function should be doing. So from henceforth, if anyone changes that function so it no longer returns true, my tests will fail, and my CI environment is going to put a nice red badge here instead of a green badge. And that happens automatically because we set CircleCI up in the first step. We're going to run that, and I'm warning you it's going to fail, and I'm going to look at why it's failing later on. So I'm calling my ci.sh script, which I showed you earlier. It's loading PHPUnit as it does, and it's giving me a fatal error. It says Drupal core string translation trait doesn't exist. Why is that? If I go back to my manager here, and the actual code I'm testing here doesn't use that specific trait, but we're using a class which requires this thing called string translation trait. We'll look at traits a bit later on if we have time. What I want to emphasize now is that we need to stay in a mindset that unit testing, PHPUnit, when we're actually testing code, doesn't know that you're using Drupal. Okay, if you use unit testing within Drupal, it might know it, but in this case, we just want to test specific code. And the main point I want to bring home is we don't really care what string translation trait is at this point. We just want to make sure that that method works as expected. So what I'm doing here is I'm basically saying, okay, let's take this string translation trait, let's make PHPUnit happy, and let's add it somewhere. So I'm going to add it here. In one of my PHPUnit bootstrap files, which basically are loaded every time a PHPUnit is run, I'm saying, okay, let's just make this thing exist. We don't care what it does. We just want it to exist so we can go on with our lives and run our tests. So once we add this specific code to our bootstrap file here, and this doesn't have to be called bootstrap. You can call it anything. It's just these little code files that you want to load every time you run PHPUnit. So now that PHPUnit loads up this code, our test should run. And there it is. We have a dot, which is PHPUnit's way of saying, yeah, the test is passing. And if we go and look at CircleCI, we should have the same thing, and here is that dot. So the magic of using Docker for local testing is you know you always have the same results locally and on your testing environment, so you can run your tests locally. That was number 4, our first working test. Okay, data providers, I want to look at that real quick. Let's go back to our test here. Okay, so in this specific case, I have a test, and I'm saying, we want to call auto entity label visible with whatever, and that should return true. But we also want to call it with profile 2, and that should return false. What does it do when we call it with an empty string, for example, or something that's not a string? How should it react? So basically, we have this concept of you have a list of inputs and a list of desired outputs. That's what the provider concept is in PHPUnit. And we'll take a look at that right now. That's number 5. Okay, here it is. So here's the exact same code. I added this if output is not expected, print out the output expected. That's not necessary, it's just kind of helpful. So we have basically one unit test here, but instead of hard coding what we want to input into our method, we're using a data provider. We're taking this as a variable and we're passing it to our test. We're defining up here what our data provider is, where our data should come from, and we can have a list of data here. So in this case, when you pass in whatever to this function, you want it to return true. When you pass in profile2, you want it to return false. When you pass in an empty string, it returns true. Using the data provider makes it a lot easier for developers to add like 20 tests, for example, for a given function. It's that easy. You just add one line to this array. So data providers, I find, are very important for making sure you cover all your bases, you cover every single possibility you have when running. You kind of bombard, shall we say, a method with a bunch of inputs, and you get the expected outputs. So, trick question. If I run this, how many dots am I going to have? 3. There you go. Why 3? Because I have 3 items in my data provider. Right? My test is being called 3 times by PHPUnit. All right. So, procedural code and static methods. I mean, we just tested a static method, but this is a pure method, right? This is like, let's go back here. I mean, it's static, but it doesn't actually use any external code. It's a pure method which always returns the same thing regardless of the application state. So we can test it. But as soon as you have a little bit more complicated code which kind of, calls some external functions, uses external classes and so on, we need to mock those out. So we can no longer use these static methods or procedural code. So we're going to kind of move away from those. And we're going to make sure all of our code is non-static and non-procedural. So oftentimes, code is like conceptually static. In those cases, I would encourage you to use something like the singleton design pattern, which I'll show you in a second, just to make sure that you have exactly one instance of each class, and you call the instance of that class, and then you call your method on that class. So just avoid using static methods. So that was number 6. Let's take a look at what our code diff is for number 6. There it is. Okay, here I'm going to give you an example of a procedural code. So I'm going to check out number 5 again and take a look at that. Prepare entity form. Okay. Let's go to our .module file here. Prepare entity form. There it is. Okay, so you have this long kind of procedural code here. There's a bunch of cases, switch. There's an if here. So you can imagine that testing this function, even if you could test it, would be a nightmare because there's so many different use cases, or what we call cyclomatic complexity. That it's basically, even if you can test it, you're never going to get all the use cases. So my recommendation to you here is to basically break that down into smaller methods that do one thing and do one thing well, which is basically a good practice anyway. I'm going to move that over to here it is. So what I'm doing here is, instead of that super long-winded, huge monster function, I'm basically calling a method instead, which is testable. And instead of making it static, I'm calling it on a singleton, which I called auto entity label singleton, which is a new class I set up. You can use a Drupal service or whatever you want. The idea is to keep your code in classes and keep your code non-static. So here I have this typical get instance type static function, which basically returns the instance of our singleton, which I used in the example. And here's my code. This is the exact same code, but now it's testable. Why is it testable? Because it's a non-static function. Okay. So we still have an issue here. Because, like, how do you start testing this? It's just a huge function, such complexity, that your first kind of step as an automated tester is to break out the part that you actually want to test. So in this case, I'm going to take a look at step 7 here. What is my diff? Okay, so this specific part of the function is what I want to test, right? I can't test everything at once, but this part maybe I determined to be critical or whatever. So I'm going to move that into its own function. So instead of having this code here, I'll replace that with, this code here. So I created a new function in my singleton called widget default value. Now widget default value is a one-liner, right? Now that's testable. Now this is a type of method, in my opinion, you want to aim towards. Having these methods that do one thing well, to the point that you'll say, well, it's so obvious what this does, why am I testing it? If all your methods are like that, you've done a good job. If all your methods are so obvious that you're like, there's no point testing it, you're on the right track to doing good unit testing. So obviously I can test that now as well. I'm going to have a class called auto-entity-label singleton test, which is a new test method here. And right, I have my widget default value. Again, the actual test function itself is not all that interesting. What's interesting is what the inputs and outputs are using the provider. So here's the provider. I'll say, well, if we have no default value, then we should get this auto entity label. Again, I don't really care why this is. I just surmise that this is what the code does. So that's what my test should do. If I have this default value that exists, it's going to return it, right? That's what I want this method to do. And if I actually run the test, I should probably have 5 little points now. And I know that that exact same code is going to be on CircleCI as well. I won't show it to you. I'm sure you believe me. So avoid static methods, avoid procedural code. Those are legacy. Move towards non-static, non-procedural code. Splitting the monster functions, what I showed you earlier, that's like always like the first step. You have a monster function. Start by surgically removing those parts you want to test, putting them in their own functions, and test those. Okay, mocking. Let's take a look at some mocking functionality here. So what am I testing? Manage type data. All right. So let's say I have this class here called entity label not null constraint validator. And then I have something here called managed type data, okay? So this is actually a super important part of unit testing that a lot of beginners in unit testing kind of have a hard time getting their heads around, including myself when I was starting out. This is not a monster function. This is something that, we can relatively easily test. However, we have this get type data, we have manage valid type. We have these like calls to external functions, external to our method, and we don't really care what those do, right? We're not going to be calling them. We're not testing get type data here. We're not testing manage valid type data. What we're testing is manage typed data. That's it. So we want to mock away these methods here, get typed data and manage valid type data, and say, well, how should my method react if get type data returns this? How should it react if manage get type data, if get type data returns this other thing? I don't care why it does it, how it does it, what it's actually supposed to do. I just want to know how my method reacts. My method is the unit in this case. We're not doing functional testing. We're doing unit testing. So let's take a look at how that works. Now, remember earlier we basically instantiated our class, or we just called a static method directly. This is PHPUnit's way of saying, well, I don't want to test entity label not null constraint validator. Because if I instantiated that and called the function I'm testing manage type data, well, that function would call a bunch of other stuff that I don't care about. Okay? What do I not care about in this case? Get type data and manage valid type data. I don't care about what those things do because I'm not testing those right now. So I'm getting an object which is kind of a mock object, which does everything my normal object does, everything entity label not null constraint validator does, except it takes away those modules I don't care about, and it replaces them with what? In the case of get type data, let's say that get type data should always return some input. Where does this input come from? Are you guys paying attention? A provider, a test provider, right? I'm passing input into my test function, and where does that input come from? It comes from my provider down here. So in this case, I want, what I'm saying here, okay, is my expected output is false. My input is some class. I don't care what class it is. It's some, just a empty class that's not a field item list, okay? And my function should return. Let's go and look at the function again. Okay? If my typed data is not an instance of field item list, in our case, it's just a regular empty class, my code, manage type data, should return false. Do we agree with this? Okay, perfect. But how do I get type data here to return something that without actually calling it? Again, coming back here, I'm creating a mock object, and you have access to all this code through the blog post. I'm creating a mock object, and that mock object basically replaces get type data with just a simple function that returns the input I give it, in this case defined by the provider, which is a new class, right? And my expected output from that is basically just in this case, false. Let's try running that code. And there it is. It passes because we're actually getting, our function is being called in a mock object, and it's returning what it's supposed to. Any questions on that, like how that works? Like the idea of mocking functions, mocking methods, mocking classes. Do we all get that? Cool. All right. So let's move forward then. Anonymous classes. I kind of use these a lot in my unit testing. Let's take a look at this here. Again, in this case, I tested that if my type data is not an instance of field item list, well, I should return false. However, how do I kind of simulate that it is a field item list? Don't forget, in this particular case, I'm not using Drupal. You could have a complete, 10 megabyte Drupal installation to test that function, but you don't really need it in this case. We just want to have something called field item list, which exists at Drupal core field item list, right? And we want to make sure that we can instantiate some object that is a field item list. So how are we going to go about that? So the first thing we want to do is make sure that in our bootstrap file, whatever it is, like the file that basically the code that's being referenced directly or indirectly in our XML file, that's being basically called every time a unit test is being run, contains this class. We don't care what it does. We don't even know what it is necessarily. We just want that to exist. So we're creating that field item list. Now, in our test, in our provider, let's go back and look at our provider here. Okay. We know that an empty non-field item list class should return false. We also know that a field item list should return manage valid type data. Whatever, we don't care what that is. And in our mocking here, manage field item data, we just set it to always return true. We don't really care what it does, how it works, because that's not what we're testing. It's always returning true. So we know that if this line of code here is being called, our managed type data method will return true, because we're mocking this to always return true. Does that make sense? Okay, cool. So we have two new use cases now to our test, right? To testing our method. If this thing here returns something that's a field item list, which also returns true to the isEmpty method, this should be called. If we get a new field item list but returns false to isEmpty, this line will not be called and will return false. And that's exactly what we're saying here with anonymous classes, right? So this is our first test case in our provider. Our second test case basically creates a new anonymous object, right? Or anonymous class, let's say. Our class extends field item list, and we'll just define a method in there which returns true as to isEmpty. And if that returns true, our expected value is true. If it returns false, our expected value is false, right? Let's try running that. So we get some extra points here. What if I remove the isEmpty function entirely from here? What would happen? Should get an error. Let's try it. I'm getting an error. Call to undefined method, anonymous class is empty. Why am I getting that? I'm getting that because it's trying to call isEmpty, and I have not defined isEmpty, because don't forget this is an anonymous class. So, good answer. All right, let's move forward again. Tested protected methods require reflection. I'm going to go through that real quick because it's kind of hard to get your head around, and I think for me too, it's really playing with my mind. But if you do have protected methods, you can take a look at that. I'll just show you real quick here. Actually, you know what? Life is short. Let's just do it. Okay, so because this will happen to you when you run automated tests on your code. So here's a new test. It's a test called get config on, where is it here? Auto entity label manager. Let's go back to auto entity label manager, get config. There it is, and that's protected, okay? Right? And I want to test this. So testing config here. I mean, this test should theoretically work, right? I'm calling get conf. I'm creating a mock object. I'm calling object where it is get config. It should theoretically work. If I run it, however, it's going to fail. Why is that? It's failing because I can't access. It's trying to access protected stuff, and it's trying to call a protected method, and it's preventing me from doing so. It's kind of hard to change a protected method into a public method. So we use what's called a reflection class. Okay, and this you can, if you need this, you can take a look at it. So the idea here is we create an object based on a protected method or property. We set its visibility to true. And then we call that property, where is it here? Yeah. So we call that property using a method of that property as an object. So it kind of plays with your mind. So the way I do it is I just copy paste. It's kind of hard to get your head around, but it's just a way to get around this idea of you can't access a protected, like that's what a protected method is. You can't access it from outside the class. So let's use this kind of workaround to access that. All right, PHP traits, want to go through that real quick because those are kind of interesting. Remember earlier we had a, let's see here, Bootstrap. Yeah, we had the string translation trait, right? Our test was not finding that, so we just created it. Traits are actually super important when you do automated testing, and Drupal has a lot of them, including the string translation trait. I'm going to go back to the blog post here to show you real quick. Yeah, so let's say you have something like this. You use something like the Drupal set message, which I think is deprecated, but still, some people still use it. So you can't test that because you can't mock it away. You can only mock away stuff that's not procedural, so it has to be in its own class. So what do we do with something like this, where a bunch of different classes use Drupal set message? You might be tempted to do something like this. So you can, when you test B, well, you can mock away Drupal set message, and when you test A, you can mock away Drupal set message. In this case, what we have though is we have code duplication, copy pasting. It's not right. So the traits are, for those who don't use them often, are this code reuse pattern where you can define a trait, not a class, a trait, which defines some methods or whatever, and you can use that trait within a bunch of classes, and it does the exact same thing as if you copy pasted this to this. And we'll look at real quick, the string translation trait does exactly that. If you run Drupal code and you need to call the T function, you don't want to call T, because T, translation function, cannot be mocked during tests, right? You want to call this T, and you might have noticed that when you look at contrib code or core code, they always call this T. Why is that? Because during unit tests, we want to mock away the translation. We don't care how the translation works during our unit tests. So string translation, defines a bunch of translation methods like get plural, T, and all that stuff. So you can use those within the context of your class. And then you can mock them away during your tests. And let's actually take a look at that. You know what? We're short on time. If you're interested, come see me after. I want to take a look at the Drupal TestSpot real quick. So all we've done now is basically not using the Drupal TestSpot. We're using CircleCI, and we're ignoring Drupal entirely. If you are submitting patches to core or contrib modules or developing a contrib module, you need to kind of use Drupal. Drupal's actually defined some ways to use PHPUnit. So let's take a look at that real quick. So I'm going to 13 to 14. Okay, so there's a few things you need to change. You can take a look at the code. You need to put your tests not in tests, but in tests /src/UNIT. Your group name shouldn't be my project. It should be something like, you know, your project namespace. There's a specific namespace thing which you have to use. I want to take a look though at one specific thing. FieldItemList exists in Drupal. So as soon as you use Drupal TestSpot to test stuff, you need to keep in mind that a lot of these classes you don't care about exist somewhere, and they have constructors, and their constructors have a bunch of stuff you need to give it to them in order to make them work. So in this specific case, I can no longer use an anonymous function. I need to use something like in this case I called a mock builder. Wait a minute, let's see here. Yeah, in this case, I'm actually calling a mock version of my FieldItemList, where I'm actually disabling my original constructor. So that's super useful if you want to mock away. If you're using a bunch of classes you don't care about, you want to get rid of those original constructors, because you don't want to actually build these classes you don't care about. You just want to get a mock version of them. What does this look like? Okay, at this point, if would you rather we kind of cut it short, or you want to take a few more minutes to look at this stuff?
A few more minutes.
Yeah, if you want to leave, I'm not going to take it personal, okay? So, yeah, no problem, not personal, I completely understand. I did want to take a look, though, I took this exact same piece of code here, unit test tutorial, and I created a Drupal project with it, just to see if my TestSpot would pick these things up. And in effect, if I look at my automated testing here, my tests pass. My tests pass because I used the Drupal way of doing things for automated testing, but they also pass on CircleCI. They can pass on both. You can use CircleCI and you can use Drupal. And in this case, on Drupal, it has its own here it's using Jenkins. It has its own kind of testing infrastructure, not using Docker. So it's a pain to get this to get the same results locally as you get on the dispatcher of the TestSpot. However, in the blog post, you'll notice I have a workaround at using Docker. And let's just see if we can quickly find the results here. Yeah, so here are the results on my. Tried to make that bigger, but I lost them. Yeah, here they are. So here are all my results, not on CircleCI, but on Drupal TestSpot, because if you have a contrib module, it's considered best practice to use the Drupal TestSpot and not CircleCI, even though it's a bit more. How about JavaScript? Super quick look if you're interested. It's in the blog post as well. There is I use a framework called AVA to do the exact same thing on JavaScript as we're doing on PHP. And let's head over here and run. Actually, let's look at the code first. I can't stop 45 minutes. Okay, let's say we have sort of a JavaScript file that looks like this, okay? We have a function called danger level, and this is really like an example. So my tsunami danger level times 4 plus my volcano danger level times 10. And then these methods actually probably call an API of some agency which sends you back a danger level or whatnot. You don't care what things do, right? We only want to test this. How do we do so? Again, if you run, here I'll run the test here using AVA, and the example is in the blog post. What does the test look like? And again, this is on Docker, so there is zero configuration locally. You just download it and you run it, either on a CI environment or on your local computer. You need to do zero installation and maintenance of any code whatsoever. Let's look at the test real quick. So AVA uses something called sign-on to stub or mock the methods. In this case, I'm saying that tsunami danger level should return 1. This one should return 2. And if that's the case, then my danger level should be 24. You can take a look at that, and you can apply that to your Drupal code as well. And I believe that I'm done. So that's it. I hope that helped you out. I will take some, let's not do like a formal question answer, but I will invite you to just come see me if you have any questions, or if you'd like to play around with your own code and say, like, how does this look? I mean, it shouldn't take you very long. If you want to stick around, just type in the CircleCI integration. I'd be stick around and help you out. Thank you.